NASA's mission is to launch a robotic arm into space within a few years. This magnificent invention by NASA will leave you impressed. Now, NASA has introduced a smart, brilliant robotic arm that will be attached to their rovers. Within a few years, they'll launch it and it will create a brand new chapter in space research. Curious to know more about this? Well, in today's video, we'll look at NASA's mission, which is about to launch a robotic arm into space within a few years. Hey everyone, welcome to the Tech United, your one-stop platform to drive through everything about Elon Musk and technology. Hit the like and subscribe button to join our community, and don't forget to press the bell icon to never miss an update. With that being said, let's begin. Another piece of cutting-edge NASA equipment is on its way to the International Space Station very soon. NASA's robotic arm, combined with the multifunctional rover module, will be launched aboard a Proton rocket. This brand new module will now serve as NASA's robotic arm's home base for the next 10 years. The NASA robotic arm, which is 7 feet long and can lift to 8 tons, can be controlled with a 5mm precision. The robotic arm's ability to glide hand over hand across the NASA module, it has joints in the shoulder, elbow, and wrist for optimum flexibility. The rover can work as a human geologist by utilizing its hand or turret grip and use research equipment, extracting cores from rocks, taking microscopic photographs, and analyzing the elemental composition and mineral makeup of margin rocks and soil are all done by the rover's hand tools. The robotic arm used by NASA is perfectly symmetrical. It has a handle and an end effector on both sides, and that each side may act as both the tip and the shoulder, which means that if you have many base points on the NASA piece, you can go from one to the next, then release your tip on the shoulder, which then acts as the tip, and handle a payload. And as a result, it enjoys the freedom of movement aboard the space station in that sense. NASA's robotic arm will be able to serve as any part of the space station thanks to its freedom of mobility and well-chosen placement, without interfering with the other two robotic arms currently in place. NASA robotic arm is completely configurable and offers many automation modes. This implies that each mission may be planned on the ground and then uploaded into the arm's computer, with the astronauts on board running and authorizing each step. The NASA robotic arm could theoretically function on its own and let the task operate on its own. It also gives astronauts on board the option of putting together a new mission on the fly if necessary. The arm will be used in a variety of ways to help astronauts aboard the International Space Station with their duties. This crew time is valuable, and the astronauts' safety is crucial. The arm can be employed for jobs that are labeled as dull, dangerous, or difficult. Robots will be utilized to, for example, autonomously remove payloads out of an airlock without the risk of an additional vehicle activity, and to place equipment on the outside. It can be utilized for inspection. It might be used to install new large modules on the space station, for example. Big items around can always be utilized to assist cosmonauts with moving cosmonauts or larger payloads, while the astronauts and cosmonauts have their hands free to operate on the outside while on a spacewalk. As a result, it may be employed in a variety of ways. The NASA robotic arm was created specifically for human-machine collaboration. During spacewalks, astronauts may even manipulate the arm from outside the space station using a remote control that has been optimized for astronauts wearing bulky spacesuits. When the NASA robotic arm first arrives at the space station, one NASA astronaut who is presently stationed there will be engaged in commissioning the arm. Later, during multiple spacewalks, a well-trained crew of bright scientists will assist with the installation and functioning of ERA. One of his first responsibilities will be to install the radiator and airlock in the new core module, allowing the laboratory to become operational and the NASA robotic arm to carry cargo from within the station to outside. They will undoubtedly learn a great deal about how to employ robots in space while working with NASA. Their robots' working environment will feed back into their engineering procedures, and they will finally know how well it performs in space. They'll also discover what they can do best with robots, what they can do with humans, and how to work together. And all of that will be beneficial when they travel deeper into the cosmos, which they will undoubtedly do at some point. However, individuals with robots may appear at some point in the future. They are interested in learning everything they can from the NASA robotic arms' experience. Another example of American space research and development prowess is the NASA robotic arm. To acquire the valuable samples, the rover's drill will employ rotating motion with or without percussion to penetrate the planet's surface. The drill comes with 3 different attachments, bits that make sample collection and surface examination easier. The coring and regolith bits are used to gather samples from the planet straight into a clean sample collecting tube, while the abrader bit scrapes off or abrades the top layers of rocks to reveal fresh, unweathered surfaces for investigation. The cylindrical drill removes samples from the interiors of rocks by breaking them off at the base. Each sample is taken into a separate, clean sample collecting tube. The sample tubes are approximately the same size as a pen light. Each collected core is 13 mm in diameter and 60 mm in length, with an average weight of 10 to 15 grams per tube. The loose rocky debris, known as regolith, is collected using a specific drill bit. Regolith samples are collected in the same way as rock samples are, straight into a clean sample collecting tube. The turret is located at the end of the arm. It's like a hand with scientific cameras, mineral and chemical analyzers for researching any planet's historical habitability and selecting the most scientifically valuable sample to store. The scientific equipment aboard the turret includes Sherlock, which is designed to examine minerals up close and is installed on the turret so that it may be put closer to its objectives. Sherlock looks for organics and minerals that have been changed by aqueous environments and might represent indications of previous microbial life using spectrometers, a laser, and a camera. Sherlock has a sidekick like the novel. The Watson camera is likewise attached on the hand and functions similarly to a geologist's hand lens, magnifying and capturing textures of rock and soil targets that the Sherlock mineral analyzer examines. Watson may be deployed near the targets within the reach of the robotic arm because of its position on the agile turret. Sherlock and Pixel both rely on Watson as a camera aid. Watson also gives views of rover systems like the wheels and sensors that are hidden from view by Mastcam Z. Because Pixel has to be able to travel near to its mineral targets, it is installed on the turret. It can identify traces of previous lives. Pixel looks for changes in textures and chemicals left behind by ancient microbial life in Martian rocks and soil. Pixel will look at the possibility of collecting samples from candidate specimens. The data it collects will be used to determine which targets are the most scientifically intriguing. A unique sensor in the turret protects the arm from harm if it comes into contact with the surface. If the robot arm accidentally hits the ground, the contact sensor instructs it to come to a halt. Robotic equipment that assists in delicate operations on Earth is powered by the same technology that powers a robotic arm used to erect the football field-size ISS. Canadarm was launched into space aboard the Space Shuttle Columbia STS-2 on November 13, 1981, and flew for the following 30 years, completing 90 missions. The next generation version, Canadarm2, launched in 2001, was critical in the construction of the space station and is still used to transport supplies, equipment, and even humans. It also assists with space station maintenance and upkeep, as well as catching and docking unpiloted spacecraft that transport science payloads and freight to the station. In 2008, Dexter, a robotic handyman, landed aboard the International Space Station. Dexter can ride on the end of Canadarm2, decreasing the need for dangerous spacewalks to complete routine tasks and freeing up astronaut time for science, the space station's principal purpose. Dexter also serves as a unique testbed for novel robotics concepts, such as space satellite maintenance. These space robots are guided by robotics specialists from the Canadian Space Agency, CSA, and NASA as they complete their jobs. Canada's expertise in space robotics has led to the creation of cutting-edge technologies for industry, health, and other Earth-based uses. In medicine, NeuroArm, an image-guided computer-assisted neurosurgery device, and the Image-Guided Autonomous Robot, IGAR, are two products of Canadian space robotics technology. Bright Matter TM Drive is a robotic digital microscope developed by Synaptive Medical in collaboration with Canadian robotics leader McDonald, Detweiler, and Associates. Modus VTM may allow surgeons to operate on previously inoperable brain tumors. With that being said, we have reached the end of the video for today. If you found the video interesting and instructive, give it a thumbs up. Let us know in the comment section what you think of NASA's robotic arm. To receive an alert anytime we add new videos, subscribe to the channel and turn on the notification bell. We'll meet up again soon. Until then, peace.